Okay, so in our similarity statement, we know that we can find the corresponding sides and angles. So M corresponds with what? Q. I know N corresponds with R. And I know O would correspond with S. So that's how we read a similarity statement. Remember, the symbol in the middle just means similar. Okay, so let's go ahead and try an example here. Oh, there's the joke for the day. Okay, so the one at the top, I'm going to zoom out a little. Okay, this says triangle ABC is similar to triangle MRG. Let's go ahead and figure out what angle M would be congruent to. Angles are going to stay congruent. They never change. The only thing that changes size, or the sides. Go ahead and fill in what we think angle M would be congruent to. And we'll see who remembers their angle symbol. Good. Good. Hector, what did you put there? A. Angle A, right? He even added in his nice angle symbol there. We have to have correct symbols there. So what we want to notice that angles still have that congruent symbol. So my angles will be congruent. But the sides are the ones that are going to change size if we're dilating. Okay, the next one are written as proportions. We can read them up and down, so we can read them vertically. RG goes with BC. Okay, I can see that those are the last two letters on each triangle. And then look at the next one. We can read them side to side. We can read them horizontally as well. So you kind of have to check both before you start. So AC is the same as MG. Those are my first and last. So I'm going to give you a second. I'll pause the video here, and I want you guys to try basically the rest of these to see if you can figure out what would correspond with GM there and what would correspond with MR there. Okay, I'm just going to call on some people to give me these answers. What I want you to notice first, I'll kind of give you an answer there. Most of us put what for that one? CA. Do you think it matters the order I put it in? Why do we think it has to be CA and not AC?
Because
That's just the pattern.
it says BC, so you have to go in order. It says.
Okay, the key word here is corresponding. That was what you wrote in your learning goal. They have to be in corresponding order, which means like if it is G to M, it has to be in that same corresponding order. So the C corresponds with the G, the A corresponds with the M. Yeah. So when I'm looking at that, I can take, if I were just given this picture, I could rewrite my similarity statement from it. Okay, I could pull out that M corresponds with A and rewrite it that way. So they have to be in corresponding order. Alicia, what did you get for that third one? AB. Okay, Logan, what did you get for angle T?
Angle T. Alright. Q.
Angle Q. Maddie, what did you get for this next one?
I didn't get to that one.
Okay, did anybody get to this one? I saw
I
some
got
over there.
it.
Kylie?
QY.
Kylie? QY. Okay, and then our last one. Anybody get to that last one?
Yes.
Antonio?
Yes.
Logan. Give other people a chance. Okay, so some of these you had to read side to side. For example, like this one you had to read side to side. This one you had to read side to side. So you always want to double check, but it should be one triangle to the other. So that is one little section of our lesson. Pretty easy, right?
Yes.
Okay. Other section is a little bit more challenging, but you guys have basically already done this, so it should be pretty simple. Alright, so we're trying to determine how one triangle was mapped onto the other. So it gave me two blanks, which means I have two transformations that happen here. What are my four transformations that I can use here? What are the four transformations I can use? translation, reflection, rotation, and dilation. So you're trying to figure out how one triangle was moved on to the other. How do I know which one is my pre-image there?
The AB.
How do I know for sure which one is my pre-image? It doesn't have prime symbols, right?
That's what I was thinking.
There's no prime symbols. So where's the next best place to look?
Small.
What comes first? Right?
Yeah, we need to know which one comes first, so we have to read the question, right? So it says, determine two similarity transformations that would map OBA onto ORG. So my first one would be my pre-image, which is which one, the bigger or the smaller? Bigger. So I'm just going to put a star there. That is my starting point. That's my pre-image. Okay, so I'm going to pause the video here so you can talk to your partner. What has happened to get OBA onto ORG? You have to have two transformations there, and I just want to hear you say words like, it's been reflected, it's been rotated, it's been translated, it's been dilated. Alright, so as I was walking around, most all of us said dilation. So I'm going to put dilation down here. I'm going to put dilation from the center O, and then I'm going to put a comma so that we can put in our scale factor. How much bigger or how much smaller has it gotten? But we'll get back to that. So dilation was what everyone said. The debate was on a reflection versus a rotation. Alright, so raise your hand if you put reflection down, which was about like half of us. Raise your hand if you put rotation down. Okay, there is a for sure way that we can figure this out, and Vince, I really want you to explain it because I thought it was a very great explanation. So he originally, as I walked around, had reflection written down, and then I saw him scratching it out to write rotation, and can you tell me why he did that?
Because it says OB is congruent to OR.
Okay, so looking at his congruency statement, he knows that OB should match OR.
And on the other side is OG instead of the OR, so it's rotation, not reflection.
Good, so if I had reflected this side, OB, it would have flipped, and this should have been the corresponding side, right? If I reflect it. So really that should be OR, not OG. So he saw that it must have been a rotation. So very good analysis there, Vince. So this is a rotation. The only other tricky part here, that's kind of the easy part, determining what's happened to it. But on the test, you're not going to get those correct if you just leave it as rotation dilation. We have to be specific. So how are we specific with a rotation? What do we have to say about a rotation? That's a reflection over like an X or Y. How many degrees and in what direction? So determine with your partner right now how many degrees has this been rotated and in what direction?
This clockwise is counterclockwise.
Okay, so counterclockwise, how many degrees? All right, Haley, what'd you put down? How many degrees has this been rotated? Okay, 180 would be starting, we're starting from here, right? That's my pre-image. 180 would take it 2 turns. So this is just 1 turn, so 90 degrees. And in what direction did we go, Kylie and Leanna? Counterclockwise. So I'm just going to write counterclockwise there. So remember, like 1 turn is 90, 2 turns 180, 3 270, 4 is all the way back to 360. Okay, so we're good there. We have to figure out how many degrees, how big or small it has gotten. In order to do that, I can just look at my picture right now, but what really helps is if we actually draw that rotation. So I'm going to pause the video here. Most of my classes remembered how to rotate figures, so I'm going to see if y'all can remember. But go ahead and take this figure and rotate it 90 degrees counterclockwise. You can do it visually or with the rule where I flip my X and Y, but we're kind of reviewing back to like early in the year. So I'll pause and let you guys try to rotate that. The way I like to do these is kind of counting like our X and Y values. So I went over 4, up 6. So I take that motion and literally rotate it 90 degrees. So if I started here on the x-axis, 90 degrees from there would be up on the y-axis, correct? So if I counted 4 here and then 6, I'm now going to go 4 on this axis and then 6 on the other axis. So 1, 2, 3, 4, 5, 6. And that should be my point B. Okay, I can do the same thing with A. I went 6 on the x-axis and then up 4, or away 4. So now I'm going to go up 6 and away 4. So it's just like I'm rotating that motion. So most of us got that picture. However you did it was fine because our pictures looked the same. But here we have to determine now how much smaller has it gotten. So I can see this is obviously a reduction, correct? It got smaller, but we want to know by how much. So my number should be less than what if it's a reduction?
1.
Should be less than 1. So we're looking for, like, is it half the size, a third of the size, a fourth of the size? So we can count our rise and run. Vince kind of was explaining it to me in terms of rise and run, and I thought it really helped. You can always just count, but let's just check our rise and run for my first one. So I went up 6, my rise was 6, and then I went 4. Yes? So I went 6 and then 4. To get to my new image, I went up how many? To my new image, you're looking at your paper. I went up 3 and over 2. So what has happened here? What happened to my numbers? I went from 6 and 4 to 3 and 2. What happened to them? They split in half. So my scale factor is 1/2. A common mistake here, what do you think would be? With my scale factor, what do you think a lot of people would put here instead of 1/2? 2. So a lot of people would say, well, that's gotten 2 times bigger, but you're going in the wrong direction. So make sure you notice which one is your starting point. All right, I'm going to let you guys try to figure this one out. So what has happened from ETHP to ODBA? So which one is my pre-image, big or small? ETHP is my first one, right? So that is my small one. So I'll let you guys think through what are my 2 transformations that happened, and I'll see if you guys can get the specific. Okay, so we're counting from the E to the O because those have to be corresponding or in the same spot. So from E to O, go ahead and count how many units we slid over. Count again. Samarians, how many units did we count? 8. So that means I'm going to count 8 from every other point, and I'm also going to translate this over. So 1, 2, 3, 4, 5, 6, 7, 8. There's E. There's P. Okay, we don't have to count the other ones. We know that we slid them all 8 units over. So I could say this is a translation. How would you write that? How would I write that specifically? Because right now that's a wrong answer. How do I make it correct? I translated it how many units in what direction?
Right. 8 units.
I went 8 units to the right. I can write that in vector form. So that tells me a positive 8 in the x direction. Or I can write it in words. So 8 units to the right. Okay, on the test, if you forget this part, it is wrong. So you have to be specific. Okay, and then we said it's followed by a dilation. I'm just abbreviating mine. A dilation from the center. And has it gotten bigger or smaller? This is an enlargement. So should it be a number less than 1 or greater than 1? Greater than 1. So let's count. This is actually super easy when it's straight across on the line. We can just count our original units. So what was EP? Count blanks, guys. How many spaces did we go? From E to P. I need words. 2. Okay, and then on my big image from O to A, count how many units are there. 6. So when we're talking about scale factors, we're talking about multiplication and division. So what number did we multiply by to get from a 2 to a 6? 3. So my scale factor is 3. Okay, so again, if you just write dilation, it's wrong. You have to include your scale factor. And that concludes our lesson for today.